So now this one, here's the problems we're going to look at now. It looks a little bit different, but here's what it relates to. It is exactly like a problem that looks like this. If I said to multiply, that would mean to distribute and take the 3 times the x minus 3 times the 2, right? That's called distributing. Then you simplify. 3x minus 3 times 2 is 6. Same thing down here on this one. If you see something out in front and it's multiplying by a set of parentheses with terms being added or subtracted, you distribute. Hopefully when you look at those and you see that bubble, that set of parentheses and something out in front, that your brain says, oh, I need to do something with both of the things inside. What is it? It's multiplying, right? So multiply 2x by x plus 2x times 8. Right, we've got 2 times x, which is x squared, plus 2 times 8, 16, and then we have this x there. Now I can't do anything further there because they have same variable but different powers, so that would be multiplied all the way. When it comes to these radicals, it's the same process, except for instead of variables, we have radicals. So first things first, if there's a radical outside a set of parentheses, you're going to distribute. All that means is you're going to take square root of 3, multiply it by 3, this guy, plus square root of 3 times square root of 6. Now it's two separate things, but look at it, it's one whole problem, but look at it as two separate pieces. And it was funny just now because I covered up part of it with my hand. You can't see what I cover up. It's always going to happen. Just ignore me. Okay, square root of 3 times 3. This guy is inside jail. This guy is outside jail. Can you combine anybody inside with anybody outside? No. So you cannot combine those guys together. You would have to leave them separate. But the 3, the getaway driver, is not usually on this side of the radical, so we're going to bump him out in front. That's where the getaway driver belongs, right? He's over here by the, garbage truck entrance, and that's how they escape. I don't know. I was making that up. All right, let's look at the second one. Okay, we've got two radicals. Trying to multiply them together. Is the shelf number the same? Yeah, there's nothing, so it's a square root. It's a 2, which means, yes, I can combine them into one jail. I'm going to write the 2 just so you can see where it came from. And then I've got 3 times 6. And again, you can either factor it from here, or if you feel better, multiply them together and then worrying about factoring it out, you can. 18 factors into 2, 3, and 3. Group size is 3. 1 makes it out. That poor 2 is left inside. So this one became 3 square root of 2. And then don't forget, this guy was in between these two things. Now, last step is to look at those and go, okay, can I add those two things together? Well, they've got the same shelf number, but they do not have the same number on the inside. So you can't. That would be your answer right there. So, same shelf number, you can multiply them together, but you can only add when they have the same shelf number and the stuff inside is the same. All right, let's try some. All right, this says multiply the following. It's got this set of parentheses, which means I've got to distribute, right? So parentheses, distribute. I'm going to multiply this by that. That was square root of 14 times square root of 2 minus, multiply by that, square root of 14 times 5. Excuse me, I seem to have a frog in my throat. Let me get him out. Okay, he's gone. Okay, let's look at this first one right here. We've got square root of 14 times square root of 2. Do the shelf numbers match? Yeah, that's the square root again. Okay, we can write it as one single square root with the numbers multiplied together inside jail. Okay, that's 28. Now I've got to try and reduce that. So we're going to break it down. That's 2 and 14. We knew that already. 2 and 7. So that's actually square root of 2 times 2 times 7. Hey, what's my group size? 2. 1, 2 makes it out. The other one dies. Poor 7's hanging out inside there by himself. Okay, that's this first one. This second one, it's a square root of 14 times 5. Outside jail and inside jail cannot combine. So all you can do is write them next to each other. And so it's going to become the 5 out in front and then your jail. And don't forget the subtract that was in between. Okay, everybody's been reduced. So we say, okay, do the shelf numbers match? Yes. Do the insides match? No. So there's nothing else we can do there. I'm going to rewrite it. So 2 squared of 7 minus 5 squared of 14, and that's the end of it because we cannot add or subtract them. All right, this one right here, the difference being that now our index is 3, which means they all have to match. When you multiply, everybody has to match. And then that tells us our group size is 3 now. Group of 3. All right, let's multiply then. Set of parentheses, multiplying, that means I have to distribute. So I've got negative cubed root of 3 times 8 cubed root of 9. There's that first one. Then for that second one, right, for this one, it's going to be negative cubed root of 3 times cubed root of 2. And then don't forget this guy right here. That was the minus in between the two distributing. Yes, we do have a negative here, and yeah, we're going to end up changing it to a plus and that kind of stuff. I know some of you see that. We'll deal with that later. Okay, so I'm going to look at this first set. Okay, I've got to multiply my outside numbers together. If there's no number written, we assume it to be a 1. So my outside numbers are negative 1 times 8. And then my shelf numbers match, so I can combine these guys into one radical. That's the cubed root of 27, which is actually just the cubed root of 3 times 3 times 3. The frog's climbing back up. Group size of 3 means I can pull a 3 out. Everybody's gone, so the jail disappears. These guys multiply together and make a negative 8. So getaway driver. You're multiplying, right? Multiplying. So this thing turned into negative 24. And the radical disappeared. That's possible. It's okay to have a radical disappear. All right, over here in red. Okay, it's two radicals. The outside number is negative 1 and 1. So it's just going to be a negative something. Then we've got cubed root of 3 times 2, or the cubed root of 6. Now 6 does not have any homies in it. It's got 1, 2, and 1, 3. So that one's going to be it. Negative cubed root of 6. And then don't forget this little guy. Now looking at that, this is negative 24 minus negative blah, blah, blah. Remember, with minus and negative, it was keep, change, change. So it's going to stay negative 24. This changes, and that changes. So final answer, negative 24 plus the cubed root of 6. Can't combine anything. One's got a cube root, one doesn't. And that's it.